Well, hi everyone, this is Bob the Science Guy, continuing our physics discussion. Today we're going to talk about vectors, and this is the first of about 3 videos that I'm going to do on vectors. We're going to introduce each concept initially and then expand on it in the next video. So, what is a vector? A vector consists of 2 things. It's got a magnitude and it has a direction. So, magnitude plus direction equals vector. If you just have the magnitude, that's called a scalar. And to give you an example and for a couple of examples, a scalar is speed. A scalar is positive. It's always positive. Okay, a vector has got speed plus a specific direction. So it's got a scalar and it's got a direction. And what we do is we use something called standard unit vectors. So many of you are familiar with the x, the y, and the z axis of a graph. So if we go like this, we've got y, we've got x, and then coming up we have z. That's coming out of the paper like so. Now it's good to think that a vector, say vector A, we'll make that vector A. Okay, vector A has 3 components to it. It has an x component, it has a y component, and it has a z component. Now, this is the way we look at it generally in high school, but we're going to use a different notation because there may be times that we want to add additional directions here. An example of something like this would be latitude, longitude, and altitude. Okay? When we start getting into physics further, we may want to add, say, time to this as well as a 4th vector. But we're not going to worry about that right now. But as a result of that, we tend to use different notation when we talk about vectors in physics. So vector A will equal vi hat plus vj hat plus vk hat. The letter with the hat on it indicates what's called a unit vector. These are the vectors in the x direction, these are the vectors in the y direction, and these are vectors in the z direction. It's just simply a different set of notation. There's no surprises here. Now, suppose we have a vector that comes from the origin, 0, 0, and comes up here to, say, 5 and 3. Looking at this, we see that that vector consists of other components. So, for example, it has an x component, which is the 5. So we would describe this vector as being 5i hat plus the y component, which is here, and that's 3, and there's no z component, and that is how we would describe this vector. Now, how long is the vector? What is the magnitude of the vector? Well, the magnitude of the vector, as you recall from Pythagorean, c squared equals a squared plus b squared. Okay, so here's a, here's b. So we say that the square root of 5 squared plus 3 squared equals c, which is the length of the vector. So if all we're given is a vector that goes from the origin to a certain point, we can easily find the magnitude of that vector by using this equation right here. And that's going to be 25 plus 9. And that is, of course, the square root of 34. So c will equal the square root of 34. That equals 5.83. What's the 5.83? Well, if this is in newtons, if we're looking for this in newtons, that would be 5.83 newtons. Okay? What about this angle right here, angle theta? Well, we know that the tangent of angle theta will be the opposite side over the adjacent side. Well, the opposite side is 3. The adjacent side is 5. So that's what the tangent of theta is. But that doesn't really help us. What we're looking for is the angle theta, not the tangent of theta. So we can use a function called arctangent, which is denoted as tangent -1 of 3 over 5. That will equal angle theta. And if we do that, all we have to do is we hit second and hit tangent, and then we take 3 divided by 5, and our answer is 30.96 degrees. Make sure that you're on degrees and not radians unless you're looking for an answer in radians. Now the next problem that we have when it comes to vectors is we'll have a vector that comes out, and we'll call that vector A, and we'll say that that's 8 units long. And then we want to add to it a second vector, we'll call that B, and that's 10 units long, and we want to figure out the resulting vector here. Okay, so how do we do that? Well, what do we have here? Now we realize that this vector is going to have 2 components. It's going to have an x component and it's going to have a y component. Well, what are those going to be? Okay, let's say that that's 30 degrees. Okay, so what is the I component? The I component is the length of the vector times the cosine of 30 degrees. Okay, 30 degrees. This would be, to figure out the math on that, cosine 30 degrees equals x over 8. Okay, because the hypotenuse is 8, we're looking for x. We just multiply both sides by that. We get 8 cosine 30. Pretty straightforward. Now, and that will be I. Likewise, opposite over the hypotenuse is sine 30. So we have y over 8. That'll equal 8 sine 30 equals y. Okay? Now, what about vector B here? Again, we have an x and a y component. And you'll also get that angle as well. So let's say that that's 60 degrees. And it is 10 long. So the I component is going to be 10 cosine 60 I. And the y component is going to be 10 sine 60 j. And again, we have 0k. So what's the resulting vector going to be? Vector C. Well, we're going to add this to this, and that is the I value for vector C. Okay, then we're going to add this to this, and that will be the j component. And once again, we have no k component. So let's go ahead and do that real quick. Okay, so I've put the values in here. 8 times the cosine of 30 is 6.928. 8 times the sine of 30 is 4. Notice that the complementary angle, 30 plus 60 is 90, right? So the sine of 30 degrees is the cosine of 60 degrees. So the cosine of 60 degrees is 0.5 times 10 is 5. And 10 times the sine of 60 degrees is 8.66. Now, all we have to do to get vector C is just add these together. So we have 11.928I plus 12.66J. And that is our resulting vector. Now, got a couple other things that we need to get from this. What is the length of the vector? Well, the length of the vector, recall that c squared equals a squared plus b squared. A squared, b squared, right? So let's do the square root of 11.928 squared plus 12.66 squared. That comes up to 303.796, and we'll take the square root of that. That comes out to 17.430. The last thing that we have to do is we have to kind of pass the smell test on this. So we've got about 17.5 here. This vector is 8. That one goes up 10. We're kind of in the neighborhood here. If we'd gotten 52 or 73 or 3, we would have known that we've had a wrong answer. But this answer looks pretty reasonable. Now the final thing that we have to do, we have the I component and the j component. We know that the arctangent of the y component, which is j, which is 12.66, divided by 11.97 or 928, will equal angle theta, which is the angle. So that's the angle between the x-axis and our vector c. So let's go ahead and figure out what that is. So come back to the calculator, hit second tangent to get the arctangent function up, and we have 12.66 divided by 11.928. What's that equal? 46.705. We'll call that 46.71 degrees. And now we've solved that problem. So the resulting vector has got a magnitude of 17.430, and it has an angle to the x-axis of 46.71 degrees. Now in the next episode, we're going to talk about dot products, which is how you multiply two vectors together. So until then, this is Bob the Science Guy. Let's go ahead and have some fun with physics.